right, let's start graphing some polar equations. So we're going to graph the equation r equals 4. When we get past some of these early equations, we will have equations that have both an r and a theta, and we would plug in values of theta and find values of r and plot them. But if all it says is that r equals 4, that means that theta can be anything. Theta can be... That's exactly what it means. So it doesn't matter what the angle is. R is just 4. So pick an angle. 1, 2, 3, 4. R is 4. Pick another angle. R is 4. Pick another angle. R is 4. Ta-da-da! Doesn't matter what the angle is. R is 4. And we have a circle. I don't know if I should bother trying to graph the circle because I think it wouldn't look very good. But I could try if you want to. Or I can cheat by using... Yeah, but you are actually writing on paper, aren't you? Oh, I should have started at the middle. Okay, noted. Control Z. So if I start at the center, ta-da! Look, I cheated. I used my shape drawer. You could. Okay. The district pays for it, so I was able to download it at home for free. Yes. But yeah, the district has a license for anyone and everyone to use it for it in terms of teachers here or at home. Okay. Next. So r equals a number again. Isn't that still going to just be a circle? But this time it's a negative number. So what does that mean? It doesn't really change much of anything that it's negative. So we just need to figure out 3 square root 2 just for graphing purposes. What is 3 square root 2 approximately? I think it's less than that. It's actually 4.2. Yeah, okay. So it's approximately 4.2, but it's negative. So that means for any angle we choose, we go backwards, technically. It doesn't really make a difference in what the picture actually looks like. So if I'm choosing angle 0, I'm going backwards 4.2. 1, 2, 3, 4.2. Or if I'm choosing pi halves, I'm going backwards to 3 pi halves, da-da-da. But it doesn't matter because either way, your radius, regardless of how the angle is associated with the radius itself, ultimately it's going to still create a circle with a radius of 4.2, correct? So this is circle radius 4. And this one's a circle with a radius of 3 square root 2. Okay, so those are pretty easy. Yes? Questions on those? See if I can sketch a circle here. Sorta. Ah! No, stop. Right there. No. Okay, I was holding a button on my pen and it was reacting weird. There we go. Okay, next let's look at what if theta is a specific number. What does that tell us about r? R can be anything, right? R is anything. Okay, so all we care about is that the angle is always going to be 5 pi fourths and r can be anything we want it to be. So 5 pi fourths would be this angle right here, correct? So as long as I'm on 5 pi fourths, I could do a +1, +2, +3, +4. I could do a radius of 0. I could do a radius of -1, a radius of -2, a radius of positive or -3, whatever. It doesn't matter. So having just theta equals something results in, like Adrian said, a line. I know that. Sorry. Are you trying to get ahead of us again? Oh, like a line, y equals x plus 2? I think that just becomes really complicated in polar coordinates. So we just don't do those in polar coordinates. We leave them in rectangular. I mean, it's possible. It just becomes an ugly equation. Kind of like we learned last time. You could actually convert a rectangular equation into polar and see what it looks like. Didn't we do one last time that looked like that? I don't remember now. Okay. Let's do theta equals negative 3 pi halves. So again, the angle is what matters. So negative 3 pi halves. So that would be going counterclockwise, no, clockwise, backwards. Clockwise to negative 3 pi halves is the same as pi halves. But then r can be anything. So that could be positive r values, or it could be negative r values. Doesn't matter. Regardless, it'll be what kind of line. Actually, like a vertical line. That's interesting, right? So this particular, no, it's not a function, but it's still a graph of a polar equation. Yeah. So this function would have been the same as the equation, just in case we care, y equals x. So it has a slope of 1, right? This one would be the same as an equation of x equals 0. And for that equation, our slope is undefined. Just to kind of compare it to what you're already used to. Okay, how many of you did what I said to do and printed or looked at that reference sheet that I gave a link to? I don't know if you did or not, but that's what I've thrown on my next screen. So let's just look at the reference sheet and we'll be able to see. We'll be able, this circle depends on the size of R. So let's look at this reference sheet really fast. Here is just theta equals an angle. We get y equals the slope times x, so we get a diagonal line. The one we just did ended up being that theta equaled an angle, but it was straight up or down. So that one was kind of an exception to this one being diagonal, but more similar to this one, a vertical line, where it just ended up with a y equals 0 equation. But normally, if it wasn't at 0, it would be this equation right here. So Adrian, I don't know if that sort of answers your question. It changes the center so that it's not at 0, 0, but it is right, exactly. Yeah. Or this one would be a horizontal. And then circle, we have r equals a or r equals negative a. We saw both of those today where it would just be a circle with radius a and the center's at 0, 0. So we can have circles where the center is not at 0, 0, and those would be formulas that look more like this. So to figure that out, you would actually plug in numbers for theta, find the values for r, and graph them, and they end up looking like this. I think we did one similar to that on our notes last time when we changed a circle equation to a polar equation, and it ended up being something similar to this, I believe. So this reference sheet should help you as you're doing the homework to make sure that you are interpreting what the graphs look like properly based on what the equation looks like. Notice that if it's cosine, the circle is centered to the left or right, and if it's sine, the circle is centered up or down. And you would take the number in front and divide it by 2, and that gives you the radius. So just some things to watch for as you're doing the assignment. But we just went over some of these really, really basic ones. Okay, this video has already ended up way